Good day, Math Buddies! Sir Sherwin here, your math instructor. Welcome to another content where we are learning mathematics lesson in an exciting and interesting way. And for today's video, we will learn on how to transform the general form of a quadratic function into the standard form or vertex form and identify the values of our h and k. But first, please don't forget to subscribe to my YouTube channel and hit the notification bell for more updated contents. Alright, math buddies, as what we mentioned a while ago, this video will give us the idea on how to transform the general form of a quadratic function y is equal to ax squared plus bx plus c into the vertex form or standard form. Y is equal to a times the quantity x minus h squared plus k of a quadratic function. And identify the values of our h and k. Let's do this. So let's try to have our first example. Let us try to transform y is equal to x squared plus 6x plus 9 into vertex form and identify the values of our h and k. So first step in transforming general form into vertex form is that we will try to group the terms containing x. In this case, y is equal to, we will group the terms containing x, and that would be x squared plus 6x. Then have positive 9 outside our grouping symbol. In this case, our a is equal to 1. Remember, if our a is greater than or less than 1 except 0, we need to factor out a. But in this case, we will not factor out a because our a is already equal to 1. Next thing we need to do is to make this expression a perfect square trinomial. So we will make this expression a perfect square trinomial by, let's copy first, x squared plus 6x by adding third term to make it a perfect square trinomial. And subtracting whatever the third term here from our given constant. So to make this expression a perfect square trinomial, all we need to do is to get the half of coefficient x and square it. So half of 6 is 3, then squaring 3, that is equal to 9. Therefore, we will add 9 as the third term of this given expression. And whatever added on our expression, making this one a perfect square trinomial, will be subtracted from our constant. So after this, we will express this perfect square trinomial as a square of a binomial. Again, square of a binomial. It follows that we have a grouping symbol and it has its exponent 2. So what would be the square of a binomial of this perfect square trinomial? That is, to get the square root of our x squared, so that would be x, sine of the second term, which is positive, and the half of coefficient x. In this case, half of 6, and that is 3. So this would be the square of a binomial of this perfect square trinomial. Then, let us also simplify 9 minus 9. The result will be 0. In this case, this is considered to be the vertex form of a quadratic function, where our h is negative 3 and our k is equal to 0. To determine our h, we will get the opposite sign of a constant present in our square of a binomial And for our k, we will simply copy the constant present outside our square of a binomial. So this would be the vertex form of y equals x squared plus 6x plus 9. Let's try to have another example. Supposing our given is y equals x squared plus 10x minus 7. So what would be the vertex form of this quadratic function? Again, to write this one into vertex form, all we need to do is to group the terms containing x. That would be our first step. So we will have y equals quantity x squared plus 10x. Then write negative 7 outside the parentheses. Then, we will make this expression inside the parentheses a perfect square trinomial. This means we will add third term to make it a perfect square trinomial. And whatever term is being added to make this one a perfect square trinomial, that is to subtract it from our constant. So here, to make this one a perfect square trinomial, we will get half of coefficient x. X here has a numerical coefficient of 10. So we will get half of 10, that is 5, then square it. So squaring 5, that would be 25. Because we added 25 in this expression, 25 now will be subtracted from our constant. Then, we will express this perfect square trinomial into square of a binomial. This means we will write this one as a grouping symbol raised to the power of 2. The terms inside the parentheses would be the possible square root of x squared, that would be x, sign of our second term, which is positive, and half of coefficient x. Half of 10, therefore, it is 5. Then, we will simplify negative 7 minus 25. So, therefore, combining these two, it will lead us to a result which is negative 32. In this case, this is considered as the vertex form of a quadratic function. So, this would be our vertex form. And to identify our h, we will get the inverse sign of the constant inside our square of a binomial. So because we have here plus 5, it follows that our h is negative 5. While for our k, we will copy whatever the constant present outside our square of a binomial. That is negative 32. So our k is negative 32. This means y is equal to quantity x plus 5 squared minus 32 is the vertex form with vertices h equals negative 5 and k is equal to negative 32. This is the vertex form of our given quadratic function. Let's have the third example. Y is equal to x squared minus 4x plus 11. Let's try to write this one into vertex form. First thing we need to remember is to group the terms containing x. So y is equal to the quantity x squared minus 4x, and let's exclude 11 from the grouping symbol. Then, we will make this one a perfect square trinomial. So we will add third term to make it a perfect square trinomial. So that would be half of coefficient x. In this case, we have negative 4. Half of negative 4 is negative 2. Squaring negative 2, that would be 4. Since we add 4 from this given expression, all we need to do is to subtract 4 from our constant. So we will try to express this one as a square of a binomial. So we will have y equals the quantity of our given binomial raised to the second power. So we will get square root of x squared, that would be x, sine of our second term, which is negative, and half of coefficient x, which is 2. So this would be the square of a binomial of x squared minus 4x plus 4. Then let us simplify 11 minus 4. So the result is positive 7. So this is considered as the vertex form of our given quadratic function. And to identify our h, that is the inverse symbol of the term inside the square of a binomial, that would be positive 2, and our k is the constant outside the square of a binomial, which is positive 7. So this would be the vertex form of our given quadratic function and the coordinates of our vertex. So let's try to have our fourth example. So y is equal to x squared minus 7x plus 13. In this case, if we noticed, the coefficient x this time is an odd number. So how will we transform this into vertex form if the coefficient x is an odd number? Let's try to find out. So again, first step is we need to group the terms containing x. So we have x squared minus 7x plus 13. We have y is equal to x squared minus 7x plus the third term. Again, whatever third term is being added here, it will be subtracted from our constant. So what would be the third term in this given expression to make it a perfect square trinomial? So earlier in our previous example, what we did is we get half of our coefficient x. Same concept will be applied. So we will get half of negative 7. So half of negative 7 is negative 7 halves. Or probably you're thinking negative 3.5. It is still correct, but it would be better to utilize our answer in terms of fraction. So half of negative 7 is negative 7 halves. Squaring negative 7 halves will be 49 over 4. So our third term would be 49 over 4. So we will be engaging now with fractions. So third term is 49 over 4, and it will be subtracted from our constant, which is 49 over 4. Then we will make this one a square of a binomial. So that is y equals square root of x squared again, that would be x, sine of our second term, that is subtraction sign, half of coefficient x, and that is 7 halves. Then, we will simplify 13 minus 49 over 4. Since we are subtracting fractions, all we need to do is to apply rules in subtracting fractions, wherein it is very necessary to have a common denominator. So if we are to combine these two, allow me to utilize this space, so that is 13 minus 49 over 4. So the common denominator would be 4. 13 is understood to have a denominator of 1. So 4 divided by 1, that is 4, times 13, we have 52. Again, 4 divided by 1, that is 4, times 13, that is 52. And 4 divided by 4, that is 1, times negative 49, we have negative 49. Then, we can now combine our numerator because we have a common denominator, which is 4. So that is 52 minus 49. The difference is 3. And copy our denominator, which is 4. This means if we are to simplify 13 minus 49 over 4, it leads us to 3/4. Therefore, we will have positive 3/4 as our constant here. This is now considered the vertex form of our given quadratic function. Y is equal to quantity x minus 7 halves squared plus 3/4. And our h would be positive 7 halves, and our k is positive 3/4. So this is how to transform our general form of a quadratic function into the vertex form. Let's try to have another example. Y is equal to x squared plus 3x plus 5. So y is equal to x squared plus 3x plus 5 is our general form. Again, first thing that we need to do is to group the terms containing x. So we will have x squared plus 3x and 5 outside our grouping symbol. We will make this one a perfect square trinomial by adding half of our coefficient x. So we will have x squared plus 3x plus our third term, then copy plus 5 and subtract whatever third term is being added in our grouping symbol. So our x here has a numerical coefficient of 3. Half of 3 is 3 halves. Squaring 3 halves, that would be 9/4. So 9/4 is obtained when we get half of 3 and square it. So that leads us to 9/4. That's why we came up with 9/4 here. So 9/4 will be subtracted from our constant. So let's try to express this perfect square trinomial into square of a binomial. So we have y equals quantity x plus 3 halves squared. Then combining 5 and 9/4. So that is, again, I utilize this space. So 5 minus 9/4. LCD, it's 4. Again, 5 has a denominator of 1. So 4 divided by 1, that would be 4. Times 5, we have 20. Then 4 divided by 4, that is 1. Times negative 9, we have negative 9. So, subtracting 20 and 9, we have 11. Then copy the denominator 4. This means combining 5 and 9/4 will lead us to 11 over 4. So 11 over 4 will be the result when we simplify 5 minus 9/4. So this is now the vertex form of our quadratic function, and our h here is equal to negative 3 halves, and our k is equal to positive 11/4. So this is how to obtain our h and k from the vertex form of our quadratic function. So let's have our sixth example. This time, let us have the value of our a greater than 1. So, supposing our given is y equals 2x squared plus 12x minus 7. So what will we do? Again, group the terms containing x. So we will have to group 2x squared plus 12x. Then exclude minus 7 outside the grouping symbol. Then, in this case, we will factor out positive 2. So y is equal to, factor out 2. So we will have 2x squared divided by 2, we have x squared. Then, 12x divided by 2, we have 6x minus 7. So we factored out 2, and we have our terms inside the grouping symbol, x squared plus 6x. These terms will be expressed as a perfect square trinomial. So we will have to add the third term in this expression. since our a here is greater than 1, all we need to do is to take the product of our a and third term, and it will be subtracted from our constant. Again, the product of our a, which is 2, and the possible third term will be subtracted from our constant. So let's try to determine now the third term of our given expression. So the third term is simply half of our coefficient x. So half of 6 is 3. Squaring it, that is 9. So again, 9 will be written in this spot. And it will be multiplied to 2. And their product will be subtracted from our constant. So let's try to simplify. Y is equal to 2. We will express this one as a square of a binomial. So we will have quantity x plus 3 squared. So combining these two, first let's simplify. 2 times 9, we have 18. So we have negative 7 minus 18. So y is equal to 2 times the quantity x plus 3 squared. Combining negative 7 minus 18, we have negative 25. So this is now the vertex form of our quadratic function. And in this case, our h is negative 3, and our k is negative 25. So this is how to obtain the vertex form of our quadratic function. Let's try to have our seventh example. Y is equal to 3x squared minus 18x plus 14. So how will we transform this one into vertex form? Again, first step is we need to group the terms containing x. So y is equal to the quantity 3x squared minus 18x, then exclude positive 14. Then, factor out our a. Our a here is 3, so we need to factor it out. So y is equal to 3. So the factored terms would be 3x squared divided by 3, that would be x squared. Negative 18x divided by 3, we have negative 6x. Then, copy plus 14. Then, we will make the expression inside the grouping symbol a perfect square trinomial. That is, y equals 3 times the quantity x squared minus 6x plus our third term. And again, the third term will be multiplied to our a and it will be subtracted from our constant. So, half of negative 6, it's negative 3. Squaring it, that would be positive 9. So we will write 9 as well on this area. Then, let's express this one as a square of a binomial. So we will have y equals 3 times the quantity x minus 3 squared. Then, let's simplify first as we multiply 3 and 9, which is 27. Then, y is equal to 3 times the quantity x minus 3 squared. Combining 14 minus 27, the result is negative 13. So this is now the vertex form of our quadratic function. So our h here is 3 and our k is negative 13. So this would be the coordinates of our vertex, and this would be the vertex form of y equals 3x squared minus 18x plus 14. The question is, why is it necessary for us to determine the vertex form of a quadratic function? It is very essential for us to have the idea on how to transform the vertex form of a quadratic function from the general form in order for us to obtain the coordinates of our vertex. In graphing our quadratic function, vertex is very important because this would be the turning point of our parabola. Again, vertex will help us determine the turning point of our parabola. There you have it. Hope you learned something new today. God bless us all.